Try this video on this example on your own, and now you're checking it with the video. So in this example, we're interested in estimating total number of NFL plays in regular season games based on number of first downs. We don't have all the data set. We have a little bit of it, and we have the means and standard deviations of each of our variables. They also give us correlation in the beginning paragraph. So first thing, we need to identify the response variable. Remember, that's our y variable, and the explanatory variable. That's our x variable. And in this question, they say they want to estimate total number of plays. So total number of plays is the thing we're trying to estimate. That's our response, or our y. So I'll label it in the chart here, total plays. There's our y. That must mean that's our y bar and our sy. And I'll jot down the answer here for reference. Total plays is our response. Explanatory variable is the one going to help us predict the total plays. And they're going to use first downs, number of first downs, to predict total plays. So there's our x bar, and our sx. And our explanatory variable, again, first downs. If you ever have trouble identifying this, always ask yourself, what am I trying to predict or estimate? That's the thing that is your response variable, what you're trying to predict or estimate. Then they want us to describe the key features of this scatter plot. So remember our key features here. We had form, association, strength, and identifying any outliers in the plot. So if you take a look at the plot, sure, this agrees with what we just said. X, number of first downs, is going to be used to help us predict Y, total number of plays. So form, there's not really any strong curvature. It looks fairly linear. And it also looks like it has a positive association. As X increases, total number of first downs, total number of plays also increases. So let's jot those down first. Form, definitely linear. Association, also definitely positive. Then let's take a peek for strength and outliers. So this is it's definitely not strong. It's not real weak either. I'd say it's kind of in between, moderate. And I don't know, these guys may be outliers, but we would have to do some tests to be sure. So strength, I'll say moderate. And outliers, let's say none, or maybe those two at the top could potentially be outliers. This answer, again, we're just kind of getting a rough feel for it. All right, next bit, we need to calculate our least squares lines. Remember, line, we need to do three things here, but our final answer needs to be in the form of the line. So hopefully you found your slope, b, and a reminder of that formula, r times sy over sx. So the correlation they gave us at the beginning of the problem, 0.724. And we've labeled our standard deviations and means up here to use. So our sy was the 9.56. Our sx was 4.49. And when you work that out, you're going to get 1.5415. Next bit, we need to find our intercept. And that was denoted with A, reminder of the formula, mean of the y's minus slope times mean of the x's. So we labeled them up here to make this easier. Mean of the y's is that 67.8 minus the slope we just found, 1.5415. Mean of the x's, 21.6. And that's going to give you 34.5036. And then don't forget, last step, put it in the form of a line. That was the original question. So our line was y hat equals a plus bx. And we said we need to be real careful to put it in context. the x variable and the y variable. So in our problem, the y variable was our total plays. And we're going to use that little hat notation to remind ourselves this is something we're predicting. We're predicting total number of plays. And the intercept that we found for that, our A was 34.5036 plus our slope, 1.5415, and x variable in this case was our first downs. So there's our final answer, several steps to that one, but that's our final answer we're looking for here, the equation of the regression line. All right. Next section is finding the slope, or interpreting the slope and intercept in context. I'm going to skip the intercept part here. If you did that, excellent. Let's focus on the slope there. That's the most important part, understanding that relationship between x and y. So in this case, our slope, we said, is x goes up by 1. This tells us how much the y value is predicted or expected to change on average. So x was our number of first downs. So as number of first downs increases by 1, okay, so always as x goes up by 1, the predicted, make sure you remember that word, the predicted y, and in this case, y represents total number of plays, so the predicted total plays. And then are we going to say, as first downs goes up by 1, predicted total plays increases or decreases? Right, hopefully you're saying increases because our slope is positive. So the predicted total plays increases by 1.5415 plays. Okay. Again, you might see some people, instead of using the word predicted, they'll talk about average or expected, and that's all fine as well. We're all saying the same thing. Okay, so let's check out the next part of this. How many total plays does a line predict for a game with 20 first downs? So this one should be easy. When it asks for making a prediction, it's as simple as plugging it into the equation. So total plays predicted, and our equation was the 34.5036 plus 1.5415, and number of first downs we're interested in plugging in is 20. If we plug that in, we're going to get 65.3336. Notice everywhere on here there's decimals, and they might seem kind of strange. How can we have 65.3336 for total plays? That's totally fine. We're talking about an average or prediction, so don't round these things, leave them as decimals. And then the last bit, what portion of variation in the response can be explained by the line? This phrase should make you think, big green light flashing. This is just asking for r squared. So really simple, r squared, what proportion of variation in y is described by the line? So here, r squared is going to be our 0.724 squared. And if you square that, you're going to get 0.52417. It says, based on this, do you feel comfortable using the line for prediction? And I'm going to say no. This is kind of equally close to 0% and 100%. It's right in the middle. It's only saying about 50-ish% of the differences in total plays can be explained by first downs. So probably not enough. There's probably other variables that would be a better indicator of the total number of plays. So here I'll say no, because r squared is not close to 1. And again, close to 1 is sort of discipline specific. If you want a rough guideline for now, you can use 0.6, but it does depend on the discipline. Get your calculators for the next video. We're going to take a look at how to find some of this information on your calculator, though you really do need to be able to do it by hand as well.